welcome back to another video of Kilk Nerd. So today's video is going to be on my very own program, Minesweeper. It's just like the classic game of Minesweeper. I've been working on this for a little while and decided it'd be time to reveal it, so here we go. So first I'm going to play just a little bit and show you kind of how it's done a little bit and what the different buttons do, stuff like that. And later I'm going to do like a time lapse of me playing it so you can actually watch the game progress and stuff. So yeah. So first of all, I'm going to show you a quick little tip here. If you want to do some quick menuing stuff, you can click alpha and then the first letter of the program, so M for mine, and there it is right there. So yeah, that was tip time, I guess you could call that. So I'm going to run the program now. So Minesweeper, and it says version 1.0 because I'm probably going to update this in the future. So you can either play or exit. Use the up and down arrow keys to go up and down, obviously. So I'm going to play here. It does a fancy little mine thing where it puts random mine. And I know you can't see it the best here, but it asks how many mines. So I'm going to do 15, I guess. So it's going to put 15 mines and it updates the progress right there. And then you can go all around. And I have purposefully made it, and by the way, there's 84 squares. I've purposefully made it so that the first square is always good. So you can click enter, the enter key to dig. So what the 1 means is in the 9 squares around this 1, there is 1 mine. So 2 would mean the same. There's 2 mines around. 3 mines, and the most you can have is 9, obviously. If you have 10, there's a problem. So now that is like the most basic-ish function of the game, I guess. It's basically what makes the game run. So you click enter, remember, to dig. Then you click the delete key right here to place a flag. So I'm going to just click it. As you can see, the flag's number goes down. And then there is a flag placed there. So I can place as many flags as I want as long as they don't go below 0. And the same is true. You can click it again to pick it up. Thank you to the TI Basic developer community who helped me with this project. Yeah, thank you a lot. You can check out the commentary, I guess you could call it, on my program, the helpful tips and stuff. So I'll have that down in the description, so you can go check that out if you want. So now we're probably going to head right into the time-lapse of me playing. So, yeah. Now that we've cleared all the mines, I would like to show you how you can make this program for yourself. So let's dive right into that. And mine. Delaware matrix A, 8,16 store into the dimensions of matrix A. Matrix A store into matrix B. Remember, when we're dealing with matrices, we do not use the brackets found here and an A or a B in the middle. You go into the matrix tab, not really a tab, kind of, I guess. And so what you do is you click second, then the X to the negative first button, and then you have 3 different tabs. These are tabs here, I would say. And you're able to select a matrix either by going with the corresponding number or using the up and down arrow keys, and then enter when you found the correct one that you'd like to use. Oops, I just went out of it. I'll go back in there. That was an accident. I'm sorry for that. So we're pretty close at the beginning, so I don't have to scroll down real far. So now you want to clear home, 1 stored into x, 10 stored into j. For I, 1, 12, output 4, 3, sub, quote, Minesweeper, and I do have a mine in the middle, 1, I. So that gives it the effect that it's kind of coming out of the calculator, or it's not all just popping up at once. It's starting here and kind of fading in, I guess. That'd be a better way to say it. X plus x is not equal to 5, store into x. Output 5, 6, sub, quote, v space 1.0. You don't have to have that if you don't want to, but I just think it adds a nice little touch just to have more stuff on the screen. And v 1.0 stands for version 1.0 because I do plan on updating this game in the future. And repeat until k is equal to 105, or the key is equal to enter, which is right here. Get key, store into k. Output 7, 7, quote, play. Output 8, 7, quote, exit. Min 8, max 7, y plus k is equal to 34, minus k is equal to 25, store into y. Make sure that you do have the commas here, otherwise it'll give you an error. Just a side note there, just so you don't have to go back and can't figure out why it's not working. Just remember to put those commas in. If y is equal to 8, output y minus 1, 6, quote, a space. Remember, to get a space, you click alpha and 0, which looks like an upside down bracket. If y is equal to 7, output y plus 1, 6, quote, space. Output y, 6, quote, the greater than sign, end. For I, 1, 38, and this number here you can change. Basically what this does is it's normally close to 38 mines on the screen, and that's where you see like the fancy little thing after you click enter to either play or exit. It does the mines on the screen and makes everything have mines all over. And I just thought 38 looked the best. And it's not guaranteed that it will always be 38. The maximum is 38 because there is 128 different squares, and the odds are in its favor that there's going to be 2 in the same square. So basically, you don't see any change in that spot, but it actually does change. So yeah, output randint 1, 8, randint 1, 16, quote, the mine. And you can do a different symbol if you'd like. I prefer the mine, the multiplication symbol, sorry, not the mine. I feel like that looks most like a mine. End, clear home, repeat until z is less than 85 and z is equal to 0. Clear home, display, quote, mines. Input z, end. Delver a, repeat until a is equal to z. Random int 2, 7, store into e. Random int 2, 15, store into f. Output 3, 1, a plus 1. So that's like the status updater right there is what that is. If matrix a at e, f is not equal to 9, then a plus 1 store into a. And 9 store into a at e, f. And basically, these lines here are guaranteeing that there will be 15 mines, because it was just like earlier when we have the random integers. There's no guarantee that there was going to be 38 different mines on the screen because 2 of them could have been in the same spot. So this was guaranteeing to make sure that it was actually the number that you put in. There would be 15 mines on the screen. Or not on the screen, but in the game part of it. If matrix A at 4, 8 is equal to 9, then 0 store into matrix A at 4, 8, A minus 1 store into A. So that's for the first square, so you can just click enter, and you'll always have a square, at least one square, that'll be available. And so that's ending that repeat loop. So now we're getting closer to the actual Minesweeper part of it. That was all just the fun stuff at the beginning. If y is equal to 8, return 4 store into y, 8 store into x. Output 1, 1, quote, space, and then a minus sign. and then the Minesweeper, another minus sign, and also a space, just in case there's a mine up there, even though it does clear home earlier. Output 8, 5, quote, flags, and then this thing that's at the beginning, I can't think, the colon, sorry. I don't know why I could not think of that. Anyways, so to find the colon, you click this button here, but first you click alpha because it's in the teal blue color, whatever you want to call it. So yeah, output 8, 11, J. For A, 2, 7, output A, 1, quote, I, output A, 16, quote, I. I found I's work the best for brackets on the side. You also can use a lowercase l. I think the I's just look better, but you can do whatever you think looks best. For B, 2, 15, output A, B, quote, lowercase x. I find it's easier to distinguish lines if you have the lowercase x than the uppercase x. You can also do a question mark, but I feel like it's kind of cluttered, and the lowercase x provides a little bit more space between each of them. But that's my personal opinion. And then two ends, end. Output y, x, quote, plus. Repeat until k is equal to 45 or k is equal to 1. So I did not mention this earlier, but if you think you have all the mines correct, all your flags on every single one of the mines, you click the clear button, which is just visible on the screen. You click the clear button, and then it will check to see if you indeed did get all of the mines. Okay, get key, store, and decay. If sum of k is equal to 24, 25, 26, 34, 45, 105, or 23, then I'm going to quickly explain what this stuff does. So basically, it's seeing if k is equal to any of these values, and if it is, it'll run the next lines because it's an if statement. It will not be triggered if none of these keys are pressed because the k value, the list here, would be equal to 0. If sum k is equal to 24, 25, 26, 34, then, and it also skips a big portion of the code so it runs faster, basically. Output y, x, quote, a space. I believe that is a space. I'll check quick. Yes, there is a space there. Y store into A, x store into B. Max 2, min 15, x plus k is equal to 26, minus k is equal to 24, store into x. Max 2, min 7, y plus k is equal to 34, minus k is equal to 25, store into y. In this section of code right here, this max here with the x in it, and this max here with the y in it, and it does go down another line. This is the movement stuff. So basically, it's checking to make sure that it is above 2 and below 15, above 2 and above 7, or below 7. So it's making sure that it stays within the boundaries, and then obviously these are the keys here, and this uses a piecewise expression, which helps with the movement and makes it very efficient and very fast. So it's pretty cool. And if you want to make your own game with character movement, I recommend these two lines right here. Output y, x, quote, a plus. If matrix b at a, b is equal to 2, output a, b, quote, a slash, or the division symbol, which is located right here. If matrix b at a, b is equal to 0, output a, b, quote, an x. So basically what you're doing right here is getting the stuff out of the way to see if it is an easy thing or if it actually has to check the 9 squares around it. And if it does not have to check the 9 squares around it, then it does this, and so it runs faster. And then it's like, if you actually dug there, then I'm going to have to run different lines of code to see if you hit a mine there. If matrix b at a, b is equal to 1, or you dug there, then del var e for I, comma, a minus 1, comma, a plus 1, for h, comma, b minus 1, comma, b plus 1, if matrix A at I, comma, h is equal to 9, e plus 1 stored into e. So basically, it's checking the 9 squares around it in these few short lines, which was way less than I originally had. And if you did look at the TI Basic Developer Forum post on that, you can see that my stuff was not quite as good as this. This runs really well. So yeah, it's pretty awesome. Then two ends to end these two for loops, and output a, comma, b, comma, e, end. If k is equal to 23 multiplied by matrix b at y, comma, x is equal to 2 plus j, not matrix b at y, comma, x, then, and if you'd like a explanation of this, the person who helped me actually gave an explanation, and I'm not going to attempt to explain it on here because I want to make sure that I don't get anything wrong. So I recommend you just look at that, and I will be happy to explain anything in the comments. So if you have any questions, go ahead and leave them down there. Okay, then j minus 1 plus 2 matrix b y, comma, x is equal to 2 stored into j. So basically, this is the flag placement stuff right here, and right here is the toggle function. So it's assuming that you already placed a flag, and it, again, has the explanation there if you'd like to check that out. Remember, a link in the description. And yeah, so I'll just keep going then. Absolute value of matrix B at y, comma, x minus 2 stored into matrix B at y, comma, x. Output 8, comma, 11, comma, quote. And I believe, again, there's a space there. Yes, I am correct. Output 8, comma, 11, comma, j. And if k is equal to 105, not matrix B at y, comma, x, not matrix A at y, comma, x, 1 stored into matrix B at y, comma, x. If k is equal to 105, matrix A multiplied by matrix A at y, comma, x is equal to 9, 1 stored into k. End. 0 stored into f. So that was the end of the Minesweeper part, and this is the end of the program to make sure that you actually won the game or you didn't and you missed a couple. That's what this is for. For a, comma, 2, comma, 7, for b, comma, 2, comma, 15, if matrix A at a, comma, b is equal to 9 and matrix B at a, comma, b is equal to 2, f plus 1 stored into f. End. Clear home. If k is equal to 1, display, quote, you hit a mine, exclamation point. Remember, to find the exclamation point, you can click the math, scroll over to the probability tab, and click 4, because that corresponds with the exclamation point, or you can go down to 4 by using the arrow key. Display you cleared. If f is equal to z, display, quote, all. So in other words, you want to have all just so you can know for sure that you did clear all of them or you didn't. Because even if you do clear it, or if you only clear a few, it will say you cleared 7 of them. And you maybe didn't remember what you put at the beginning for however many mines you did. For example, let's say you did 23 and you didn't remember that. So you know that you actually did clear every single one of them. I don't know. Yeah, my explanation was probably not the best, and I do apologize for that. Display f, comma, quote, all of the mines. And that is the end of this program. That's all you need to play Minesweeper. It is a fairly large program. It is 900 and some bytes. I can check that really quick. I believe it is 983 bytes. And so while I check that, I hope you did enjoy the video, and I hope if you're not subscribed, I really hope you do. Yeah, so it is 983 bytes, and so that's the end of this video. I hope you enjoyed, and if you're not subscribed, I do hope you do, and if you are subscribed, thank you for being part of my community here. So, I hope you enjoyed the video, and thank you for watching.